All right, question number 18 looks like a review. We just want to find the derivative of the following. We have y equals sine, and then in parentheses, sine of 3 cosine of x. So this is the argument. We're going to need to do the chain rule for this one. So it's going to be derivative of the outside, leave this the same, and then times the derivative of the inside function. And then you would leave this the same and then do the derivative of this inside function. So it's almost like a chain rule. Derivative of x is 1, so that third one we won't have to do a whole lot. But you do need to be aware that if this was something other than x, like it was 3x or x squared, you would have to do another chain rule part. So y prime or dy dx is the way that they're writing it. Derivative of sine is cosine. So first I write cosine, and then I leave the inside alone. 3 cosine of x. And then I multiply this times the derivative of the inside. So coefficient will stay. Derivative of cosine is negative sine. Okay, leave that inside alone. Derivative of x is 1. So you can write that times 1 just to kind of keep yourself aware, but this is it. I'm going to multiply. This will be a negative 3 coming from here. And then we can write sine x times cosine of 3 cosine x. So this will be our derivative. Negative 3 sine of x. And then cosine of 3 cosine x. All right, then question number 19. It wants us to locate the critical points of the following function. Use a second derivative test to determine if they correspond to local max or min or neither. So 4 parts. First, we want to know what are the critical points. Find the first derivative. Negative x cubed plus 12x squared. F prime negative 3x squared plus 24x. Set it equal to 0. Factor out a 3x, a negative 3x. Let's just say negative 3x. That will leave me with the x. Negative 3 will give me negative 8. Set it equal to 0. We'll get x equals 0 and x equals 8. So I get 2 critical points off the first derivative. Locate critical points, then use second derivative test. Okay, so critical points from the first derivative are 0 and 8. All right, part 2 says find the second derivative. All right, so starting here, we're going to find f double prime. So power rule again, 2 times 3 is 6, negative 6x plus 24. So negative 6x plus 24. Then we want to know what are the local minima and maxima of f, and then starting from original or first derivative, run some tests, negative infinity to infinity, 0 and 8. So numbers to check, let's just say negative 2, positive 1, and 10. Looking for the signs only. If I plug in a negative, negative times a negative is a positive. So I'll get a positive for the first factor. Plug in a negative 2 here, I'll get a negative. So a positive times a negative, this section will be a negative. Plug in 1, that will come out negative. Plug in a 1, that will be negative. Negative times a negative is a positive. So I'm going from down, decreasing slope, to up. That's a minimum. And then plug in 10, negative, 10, positive. Negative times a positive is a negative. So I'll go up to going back down. So all I'm doing is doing a little bit quick math. So what I'm doing, if you're not aware, 10, 3 times 10 is 30, but it's negative 30. And then if I do 10 minus 8, it's a positive 2. So I'm just looking at those signs, not the actual numbers. So we're looking at a minimum at 0, maximum at 8 in the interior. Local minimum at x equals 0. And then maxima at 8. Now I didn't do the second derivative test. I do remember it saying that. What we would do is find the second derivative, and we can just plug in these numbers 0 and 8. So when I find second derivative, if I plug in a 0, this goes away and I get 24. Second derivative will just tell you that immediately. If I do second derivative of 0 and I get 24, that's positive, greater than 0. That tells me that that's going to be a minimum. When the second derivative is greater than 0, minimum. Second derivative less than 0, maximum. That's that concavity. The greater than 0 is going to be concave up. So when you think about that, concave up is giving you that low point for a minimum. Second derivative is less than 0. So if I plugged in an 8, that would be 48, negative 48, and give me a negative 24. So the value is negative. So that tells me it is less than 0, which means concave down, opening down, gives me a maximum. So that's how you would use that second derivative. I'm just used to kind of seeing it and looking at it that way.